Okay. I haven't had time to prepare the release yet. Maybe we'll do that tomorrow, I think. I hope. Okay. Let's see. Are there any special topics someone wants to discuss?
Hi, Tim. This is Nigel.
Hi, Nigel.
So, how are things going?
Very good, I would say.
Good. So I have a small question. Maybe you've seen the email that I've sent.
Oh yeah, I saw. Yeah, but maybe you can ask the question again.
Yeah. So well, you know that we have been working on the combustion model, and I'm now working on the generalization of this model, such that in the configuration file you can specify the number of transport equations. So that means that at compile time, you don't know how many additional transport equations you want to solve. And this is causing a problem for the way that we are dealing with the history output. So there is this Python script, for instance, that goes through the C++ files and basically grabs the lines and let's say the keywords that he finds in these lines are then used in the history output. But yeah, obviously we don't know at compile time how many transported scalars we have, and also we don't know how they are called. So a simple solution is just add, a dozen transported scalars there, but that's not a very elegant solution. So actually, my first question is, at what moments do we actually? So why do we actually need, this? Why is it implemented like this? So why do we have this Python file that goes through the C++ file? Why not just write these history lines directly to some file? So maybe there is something that I'm not using, or maybe there is some history behind this.
Well, so this to get these options in Python, this is just for the legacy. Well, not for the legacy, for the current Python framework that we have, because there, yeah, the output was hard coded in the Python files, or is hard coded. So the Python framework needs to know what kind of output we have, so that you can set like an objective function or something like that. But that should all go away, hopefully, because ideally, like you said, I mean, the Python framework should not know about the output in any case. I mean, it makes no sense. For the optimization, it just pass down the objective function to the C++ part, and then that's it. And that also is the goal then of the new Python framework, and also of the updated output that I'm preparing right now. So yeah, at the moment it's really like that, and it's really a problem. I don't know how to solve that for in short term.
Yeah. So, but you are working on this, and it will change in the future the way this is being.
Exactly. I mean, ideally, like I said, the Python framework should not know about that at all.
Yeah.
And that's what we try to achieve essentially. Yeah.
Okay. Yeah. Yeah, because I can spend a lot of time now on trying to generalize this, but at the moment it works. It's just that I now have to hard code, let's say the names of the transport equations if I really want the correct names.
Yeah.
But yeah, if this will change anyway in the future, then.
But do you rely on the Python optimization framework at the moment, or are you just dealing with the C++ part at the moment?
Well, I am using the shape optimization, if that's what you mean.
Yeah. Okay. And of course, there's probably a way to hack something in so that it works.
Yeah.
And that's probably the way to go at the moment, I would say.
Yeah, exactly. So the easiest solution for me now is to just, usually we have the same transport. I have the same transport equations anyway. So for me, it's no problem. But in the end, if somebody else wants to use it and he has other transport equations, then it would be nice to have this more generalized.
Yeah, of course. But I think it makes no sense to think about a solution for you right now. Because that will change. Okay. I hope soon, but it's hard to say when.
It's somewhere on the to-do list.
Exactly.
All right.
Hey guys, I just joined a second ago and I wanted to say I recognize that voice. Hi Nigel, this is Tom.
Hi Tom, how are you?
Glad you joined.
Yeah.
Nice to hear you.
Some hacking stuff instead of meetings about management stuff.
Perfect. You're always welcome here, so we can talk code anytime. Good.
Great. Yeah.
Anyway, carry on. I don't want to interrupt.
No. Yeah, so I guess that means that for this specific topic, I will just wait until it has been generalized from your side, and then probably everything will be solved for me as well, more or less automatically.
I hope so. Yes. But that's the goal. Yes.
Yeah. Another thing that I noticed, and I think there was also somebody asking on the forum, is there was a guy asking on the forum, if I use axisymmetric flow, then I have convergence problems. And I noticed the same thing as well. And this is connected to the combustion model as well, because of the way it is implemented. So basically, axisymmetry introduces a source term. But if the source term is too large, then I think linearizing your system and then using this implicit order method is not the most stable method to deal with this problem. So this is probably the reason that axisymmetric flows do not converge as good as simple planar flows. But I was wondering if somebody has looked into this. Do you know?
For time integration, well, we talked about this, I think, a couple of years ago now. Nice. So I think you had suggested trying to reformulate the source terms. So like do maybe a integration by parts or something and split it into convective part. I don't remember the exact. You had sent a reference that talked about how to split that term.
There are several options that we have. I was just wondering if somebody also noticed, specifically because I guess there are more people that use 2D axisymmetric flows. So they should also experience the same problems.
Yeah, so as a high-level overview, my experience is, yes, it converges more slowly, and it's certainly the source term. In the incompressible solver, the one you're using, NISO, we put in both the convective and the viscous parts of the source term. In the compressible code, it's currently just the inviscid parts of the source term. So convergence is probably even worse, if I'm honest. So I know that one of the students in Juan's group is looking at this. So Wally, I don't know if he's online, but he was looking at it for the compressible code because he has some very high mock situations where he wants to run axisymmetric flows. So there's at least one student looking at it, but that's about all I know of. And I don't think that anybody's looking at the time, like, more sophisticated time integration techniques for the source terms there. So if this is something you're interested in, not to throw it back at you, but it's open for the taking. Nice.
Yeah, that's wonderful. Yeah. Because at the moment with the combustion model, we don't have issues with convergence, but it might be something that pops up in the future if.
Wow, can we quote you on that? We don't have issues on convergence.
Well.
That's amazing. That's good.
Yeah, if your lookup table is of high quality, then it converges actually quite well, I'd say.
Ah, fantastic.
So, yeah.
Good.
But yeah, I guess the source terms in our case are not are formulated maybe in such a way that that convergence is quite good, but yeah, it might be that for certain cases we also run into the same problems as what we have for the axisymmetric case. Yeah.
Got it.
So yeah, I will have a look at what kind of options we have there then.
Yeah, that would be great, because I think whatever you come up with for that particular problem, I mean, we treat all of the source terms the same with this piecewise constant approach. There really aren't too many other options. So depending on what you come up with, if we can generalize it, we could try to apply it to all of the stiff source terms.
Yeah,
that'd be great.
I guess it's probably something that's not directly coupled to that we have piecewise constant or not, but maybe also that we, for instance, we linearize the system of equations in this implicit Euler method. So maybe we need to do something there and introduce some, inner iterations somewhere at that level.
Maybe one other question. I haven't looked at it in quite a while. Do we have the Jacobian at least implemented for the version that's there right now? So we should at least have, the derivative of the source term with respect to the conservatives or the primitives at the point. Is that true? Do we at least have the Jacobian of those terms? I would have to go look.
Yeah, me too.
Because if we don't, then that's a clear win right there. We definitely need to add those. That would improve convergence immediately.
There, but
I think for the incompressible code, it's there. Pretty sure I put that in, but I could be wrong.
Yeah, I have to check. Flow sources. Well, I can.
There.
Did you say it's there, Peter?
Yeah.
I see a Jacobian symmetric. Yeah. Yeah.
Okay. Well, then maybe we need to do something more sophisticated if we already have the Jacobian. Well, at least also make sure that we have it implemented correctly, so none of us are error-free. So there could be some bugs also.
Yeah.
Okay, that sounds great though. If you have time to look at that.
Is there an issue already open? Otherwise, we can maybe open like an issue on the tab.
I doubt there's one open. Probably not open. Yeah, nice. So are you able to kind of get on GitHub and comment and post, or is that something that you're a little restricted and can't really do?
Well, I am in this development group, so I have to check what I can and cannot do. I think
Okay.
the restrictions are mainly with regard to, posting,
I assume it's code,
wash
right?
geometries and stuff like that.
Well, yeah, and geometry. Okay, well, I guess it was more for us as a reminder. So if you can hop on GitHub and post things, just open up an issue so we keep this in mind. We keep working on it, and we can discuss there also as you go.
Yeah. Yeah, I'll do so. All right.
Great.
Okay. That's all from you, Nigel?
Yes, that's all from my side. I gladly leave the floor to somebody else.
Okay, if someone else has questions or concerns or topics or whatever.
Hi, all. Arturo Cajal again, transitional models. So I still having the same question. Last week I asked about the implicit calculations, why the Jacobian for the source term is not taking into account the production term for the first equation, and then the production term when computing the derivatives of the term with respect of the conservative variable. So for the first equation, the production term is not taking into account when computing that derivative, and then for the second equation happens the same for the production and for the cross diffusion term. I got referred to this fixed bug for the Jacobian in the SST source term issue in GitHub, the 491, and it basically says that the Jacobian 01 was missing one derivative. But back again, it's not taking into account the production term for the first equation. So I'm just wondering what's going on. I got also referred to the Scarborough criterion, but yeah, I haven't been able to make a lot of progress. So I'm not sure if Tom, now that you were talking about the implicit calculations, you can maybe give me some other ideas.
Sure. So in general, this could be better documented, but in general, whatever there is, folks either, if something's not implemented, essentially what I hope happened is somebody made a decision that either implementing that term did not improve convergence, or in some cases it hurts your convergence. So if it hurts diagonal dominance of the system, sometimes it's best to just leave certain terms out. So what I'm hoping is people have made that decision based on performance criteria. It's possible it's a bug. And just as a small note, I mean, remember also that what we put in the linearization should not affect the final solution if we get to convergence. So even if some of these terms are missing from the Jacobian, as long as we converge and the behavior of the convergence is what we want, it's quite good, then it's okay. So just to come back to it, maybe this was an oversight. Maybe somebody ran some tests and said, you know what, adding that extra term doesn't really matter. So it's something we could do. So if you want to add the term, run the same case head to head, see if it improves convergence or not. That's typically how we've decided in the past.
All right, sounds good. Probably I'll try to do that and see the effects on the SST model, and then base my work on that to the transition models.
Great. Yeah, I mean, in general, we adding extra terms to the Jacobian is, the more exact it gets, in theory, the better the convergence should be.
Yes.
But that's not always true. And sometimes the approximations we make, it can actually end up hurting some of the properties of the linear system that we build. So it's kind of a case-by-case thing. And again, just to reiterate, it could just be an oversight. So if you find things where you think we're missing terms, it's definitely good to investigate. So,
all right, sounds great.
Yeah, because part of what I was saying in the GitHub post is that I think right now there may be only a couple people here and there that are touching the turbulence models. So I think if you find certain things you want to investigate, I think you're kind of our leading authority at the moment to digging through the details of the turbulence models. So
sounds
yeah,
good.
don't be shy. Just go ahead and try some things and make some changes if you need to.
Sounds great. Also, probably now taking the chance. Why is the derivative it's computed as a projected vector?
Why is the derivative? Sorry, could you repeat that? Not sure I understand the question.
Yeah, sure. For the viscous term, we have usually the mean diffusion term multiplied by the gradient. Let's say for SST dk dxj. So when computing the derivatives of that term, the gradient usually is computed as a projected vector. So I'm not sure yet why is that the case. If my question.
Oh, you mean the Jacobians, or like the Jacobian terms?
Yeah, exactly.
So we make an assumption in the viscous. So okay, the viscous term is really quite nasty if you want to do an exact Jacobian, because we have the gradients in there. So it'd be we would have to do it properly. You would have neighbors of neighbors, and it would get pretty complicated. The stencil would get quite large. The memory would get very the memory requirement would go up quite a bit. So what we typically do is we only the Jacobian approximation basically looks at 2 points and an edge. And so we only take information along an edge between points I and j, let's call it. And it turns out if you sort of drop, I think in some places this is called a thin shear layer approximation or something.
Yes.
We basically drop all the terms that involve neighbors. So if you only look at I and j, it turns out that the Jacobian is very simple. It's like I think it's what you're referring to as the projected Jacobian or something. It's basically the correction we apply for the gradient, not the actual like diffusion term, and it's like the whole thing. It's like basically when you take the derivative at that point, we end up with just a very simple term along the edge, and that's what we end up using. So it's kind of a rough approximation, but it's actually a pretty standard one for unstructured grids. Yeah. Right. You might take a look at. Do you have the book by? Well, geez, who goes through this? Blazek, maybe.
I think I don't.
You don't. There are also some papers by the Fluent folks. So there's a paper by Weiss and others where it's like implicit RANS calculations on unstructured meshes, and I think they talk about this approximation. While we're talking, let me try to find it in the background, and I can try to send you a message if I can find it.
I'm also gonna start looking into that. But thank you, Tom.
Yep.
Let me just add that in the Blazek book there is also a small chapter on exactly this thin shear layer approximation. It's not huge, but there's a known chapter for that in that book.
All right, just to double check, thank you. It's Blazek is Blasik, the author, I guess.
It's Blazek.
Sweet.
Yeah, that's a great book. It's very close to a lot of the things we do in SU2. So it's a good reference. Yeah.
Sweet. Thank you.
Okay, someone else? Doesn't look like it. Any other topics?
Oh, there must be.
I'm also surprised. Then what could be a good topic to discuss? Someone has an idea?
Well, pull requests are always good. We could walk through some of those if
Yeah, I'm just looking at
There's nothing else?
the list. I'm trying to do the restructuring. That's good. It means we are almost finished with splitting all the files and stuff like that.
Yeah, maybe we should chat about that for a second. What's the status? What's left? So I think we made a list probably in the issue a couple weeks ago.
Yeah, let's have a look. Did we make a list somewhere? Can't remember.
Well, we left a couple comments on the GitHub issue that was open, the one that's been open for a long time. I don't know if I thought I put people's handles there. Maybe not.
Restructuring the files. Yeah. Yeah, you are right. I think we have most of it. Let's see how does it look at the moment. I wanted to move the MPI structure. Okay, haven't done that so far. But other than that, it looks good.
Yeah, so once the files are in place, I think then we could do some of the larger changes, like if we want to eliminate folders and group things in the build files a little bit differently.
Yeah, exactly.
Well, and by that I mean the top. Of course, I want to keep the folder structure that we've created below, but if we want to start moving around things out of SU2 CFD, for instance. Yeah.
And we already agreed to removing like the include or the separation between include and source, right?
Right. Yeah.
Yeah, and then generating like some small libraries for each of the folders, maybe, or something like that.
Yeah. I think that makes sense for me, but that's just my vote.
Yeah, I mean, we can start with that very soon, actually. Mm-hmm. Yeah, and then what was the idea with common SU2 CFD on all these folders?
So if it were up to me, I would remove them and just have our folders that group things by kind of logical, areas or.
So merging the source folders essentially from common and SU2 CFD.
Yeah, I mean, for me, it just feels like an extra level that isn't quite necessary. I mean, we barely use the other folders. So like SU2 Def and, et cetera, it's like one CPP and then there's not much else in those folders. So it feels a little useless to separate it that way.
Source, shove everything inside source, includes in CPPs, and then have a separate one for applications. I think that was more or less what it was coming down to.
Yeah.
And this is open, of course. So if people have strong opinions, please share before we just.
It's probably not a strong opinion because, I mean,
We can actually rename common to just source, move the bulk of what's inside CFD to that, and that's it. And then you're left with, SU2 CFD, SU2 Dev, and that's just the application, I guess. I don't know. Do those need separate? Do you need separate build files in Mastodon or to kind of produce separate applications, or can you?
No, you can have multiple targets in one file. That's not a problem.
Okay, so they can even be together if you want, and it's just like one big library and then one folder for applications. I don't know.
Yeah, or you put the CPPs even inside of. So if there's a source folder, I'm open to whatever we want to call the top level thing. You could argue you could even get rid of the top level source and just put all the folders at the root, but that might be too cluttered. But yeah, we could just have a folder in there that has all the mains. So one of them just for like the binaries, essentially, or the executables, applications, alongside all the other stuff.
Mm-hmm. No, sounds good.
So then any concrete step there? So Tim, you still want to move the MPI stuff, right? So should we wait on that and then do the final?
Yes. I mean, I can do that this week or next week. Let's see. It should be very simple, actually.
And maybe while there's just a second, Arturo, if you're still there, I found the paper I had in mind, written by the Weiss et al., the folks at Fluent, that talks a little bit about the simple approximation we make for the viscous Jacobian. So I just posted that in the chat. And then I guess just to reiterate, I think, Arturo, you and probably Guillermo are the two that are digging around in some of the turbulence model and those equations right now. So like I said, if you see anything, feel free to make some modifications and propose some changes. So.
Mm-hmm. So what else do we have? Not that much going on this week. I think we can merge in like a lot of stuff before the release. So I plan to have the release tomorrow, I guess. Oh wait, maybe let's wait until Friday, so that we can merge in the rest of things that are open. And at some point, we should also think about having a minor release. I think that would make sense. Anyone has an opinion on that?
Yeah, when was our last one?
Output, I guess.
Yeah, for those, I think we should just base it on features. So whenever we feel like we have a good snapshot.
Yeah, okay. I mean, we can see what which features what features we had over the last 6 months. Well, since the last major release.
Yeah, actually, there's been quite a bit. I mean, especially bug fixes too since 7, so it could be good.
Yeah, that probably should go along then with some updates in the documentation and things like that in tutorials. I mean, I don't think there were that many config options that have changed.
Yeah, I don't think so since 7. I think, Pedro, you were moving it. Well, you have an open issue to move some things around or remove some, but I don't know if any of those have changed yet.
The options.
Yeah, the config options, yeah.
Yeah, I do.
I mean, if we decide on a date, then we can merge these things in or make these changes.
Well, it's good to set a deadline. So what do we think? Maybe by the end of July, give it a month, and then call that a 7.1 or something?
I think that would be good, right? Then we have at least roughly the schedule of every 6 months.
Yeah, I think having at least a 7.1 would be good before an 8 later.
Definitely.
I mean, the good news is if people are using the code right now, I mean, with pushing a maintenance release every month, people are getting everything, whether they know it or not. So I think the minor releases are more to, like you said, update some documentation, make it clear what features are available, etc.
Yeah, so far we marked all of the features essentially as experimental in the changelog.
Mm-hmm.
So we need like an updated changelog then. Well, maybe we also have to reevaluate some features. I mean, I don't know. Maybe it's also a good time to remove some stuff actually from the code.
Always good time to remove some stuff. I mean, I think Giant just took out the SU2 MSH, which has been there for a long time, waiting to get cut out. So that's good. These kinds of things are good. I think, yeah. I mean, Tim, I think another one is not that this is on you alone, but the old legacy output stuff. I mean, that's a ton of lines of code that we could probably.
I was still waiting on. I think the only reason why it's there is for the turbo machinery things, as far as I can remember.
Yeah, I think so.
I mean, I would be happy to remove it once and for all. Yeah, but maybe I will do like a small cleanup then. I will open a pull request where we can just clean up things.
Yeah, Tim, if you're flipping through the pull requests, I guess another question for you, since you have a few of them, is status on modules and the other output stuff. So do you have a target in mind, or is that still all kind of experimental, or you're still exploring?
I don't know. I don't think that I can finish it until the end of this month.
Okay.
The output, because there's still like I have to port over some things, especially when it comes to computing the aerodynamic coefficients and things like that. Still not everything is there. But
what do you need?
Sorry?
What do you need to do?
So for the flow solver, it's not that complicated. I mean, I already have everything moved over, but I have to think how I do it for the final element solver, because there I cannot just extract it from the solver and just copy it over.
From the high order finite element.
Yeah, sorry, for the higher order. Yeah, exactly.
Yeah. well, I cannot be much help with that.
But maybe it's not as hard as I think. But I had a look at it, and it's not as easy as the finite volume solver.
Yeah, I don't know, but I would suggest extending the deadline then, because this kind of output would be one of the things that you would make it like a major headline of a new release, of a middle version increase or something.
Yeah, it makes sense actually. Well, then let me aim for the end of that month. Maybe it's good that I have then like a deadline.
It's always good to have deadlines.
Yep.
Definitely,
Deadline.
yeah.
Make the world go around.
Yeah, I will aim for that. That's maybe it's a good idea.
And so, do we remove the grid adaptation now, or wait for the next for the middle release then?
I mean, that's not. I don't think that it is important when we remove it, right? I mean, it should not affect anyone at all.
Yeah,
It's a
I would
matter
say
of it's a matter of correctness. Usually, things that break compatibility should not be minor releases. But that's just what people usually say.
So you think we should wait for the minor release?
Well, I only read like the semantic versioning guidelines one time, and that's what people say.
Yeah, I mean,
Actually, they say if you break backwards compatibility, it's a major increase
yeah, it makes
in
sense.
version number. And
we
the whole
should-
purpose of the thing is that tries and puts some discipline in you, so you don't break the compatibility of the code for people all the time. But yeah, I don't think anyone's using the adaptation. So
maybe it would make really sense to have like a separate branch for these changes. So separate branch for the minor release.
yeah, and you start staging the things there. Maybe yeah.
Yeah, exactly. That might be a good idea.
So that at least like major changes don't create conflicts with each other. I don't know.
Yeah. Otherwise, we have like a lot of pull requests open there. They just wait for the next minor release, which is like, yeah, makes probably no sense.
Well, in this case, it's just a month, so it's not.
Yeah, no. For this one, it's okay, but I'm talking just in general.
And maybe we can ask Katarina as well. What is the deadlines on their side? Because that would be also a major feature, right? The Nemo solver.
Yeah, exactly. Yeah.
Mm-hmm.
Yeah. Okay. Let's see. We can ask them. I mean, it's not a big problem if we just move it, extend it by 1 month. Then we do it maybe in August. But we can talk to them. Yeah.
Yeah, so I can say just a word about what the plan was. I talk to them every couple of weeks, but I think the goal was to get, even though it's not really kind of feature complete, they wanted to get the structure into develop as soon as possible, because they've been, I mean, as you guys know, if you keep a large development alongside develop and try to stay up to date with it, you get conflicts like crazy, and it just gets very cumbersome over time. So yeah, they want to get that in as soon as possible. We'd have to ask them whether they're okay with sort of turning it on, or whether they want to just have it in develop and maybe put an error, like throw an error if anybody tries to use it at the start. But I know that they wanted to get this truck, like the skeleton, in as soon as possible. And it's already functional. I don't want to say it's just a skeleton. It's a lot more than that. But some features are not there yet that they're still working on.
Yeah, sure. So long as it doesn't go with, well, anyway, I commented on it already.
Yep.
Okay, we can just ask them and see what they think. Yeah, maybe they want to have it the same way as the FEM server. They just want to have it there. Yeah, that might be true without advertising it. Okay, good. Then the conclusion is we aim for end of this month with a possible extension.
Yeah, good. I think it's good to just have something in mind. Otherwise, it just floats out there. So.
Okay, nice. Okay, perfect. I mean, if there aren't any further topics, we almost hit an hour again. We still have a couple of minutes left in case there's something. But if not, then I would stop it here. Okay.
Okay.
Then release on Friday. We try to merge in the rest of the pull requests. And then we'll see each other next week.
Okay.
Yeah, great.
Sounds good.
Okay.
Thank you all.
Bye-bye.
Okay. Later, guys.
Bye. See you.
Thanks, everybody. Bye.